Welcome, stargazers. Could you, at any point, accept it? Picture a heavenly occasion so gigantic that it creates shaded areas on Earth, noticeable even without really trying to hide. That is the display we may be near, the very edge of seeing in the Orion group of stars. The star Betelgeuse is acting bafflingly, alluding to a looming cosmic explosion that won't illuminate our sky like ever previously. Yet, when will Betelgeuse go supernova, and what will it resemble? As per researchers, what secrets could this heavenly occasion divulge? Join us as we plunge deep into the subtleties of what's actually the deal with Betelgeuse and the effect it could have on Earth, and maybe for the whole nearby planetary group, found roughly 650 light-years from Earth in the heavenly body Orion. Betelgeuse isn't just any normal star, it's a red supergiant, one of the most luminous stars known to us, sparkling with a splendor north of 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out for its brilliance, as well as for its history and importance in human culture. Named after the Arabic expression Yad al-Allah, which means the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for centuries. It has been a guide for voyagers and a source of wonder for stargazers, with its rosy tint distinguishing it from other stars in the Orion constellation. Can you imagine a single star dominating our whole solar system? To give some perspective on the sheer magnitude of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such titanic extents? At 10 million years old, it's much younger than our 5 billion-year-old Sun. Yet, Betelgeuse's enormous size means it consumes its materials at a much quicker speed, predicting a more limited life expectancy than that of other stars. Now this divine behemoth, crossing a volume large enough to contain more than 1 billion of our suns, is approaching the finish of its life cycle. When stars of such size reach their twilight years, they don't disappear. They exit with an extravagant flare, a supernova explosion that is beyond human comprehension in terms of its energy and brightness. Such an event can potentially eclipse a whole galaxy, creating shaded areas of brightness across vast distances. The last time Earth saw a supernova this nearby was in 1964, long before the advent of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way system with the naked eye, visible for over a year and a half. It was brighter than any other star in the night sky and, remarkably, remained visible during the day for a while. What secrets do these heavenly remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, reported the presence of this new star. Intriguingly, remnants of this blast, as a growing debris cloud, can still be observed today with advanced telescopes, providing us insights into the violent ends of massive stars. Generally, supernovae have been rare witnesses on Earth, but imagine for a moment a supernova so intense that it rivals the brightness of a full moon, creating shaded areas on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially affecting satellite operations and possibly even the climate. Betelgeuse, with its capricious dimming patterns, suggests it may be preparing for a particularly grand display. Might we be nearing one of the universe's most dramatic events? Astronomers made a startling discovery between October 2019 and mid-2023. Betelgeuse underwent a remarkable change that drew the attention of astronomers and enthusiasts worldwide, known as the Great Dimming. The star's brightness, which had been stable for decades, began to diminish significantly. This sudden change was so pronounced that even casual stargazers noticed it while comparing Betelgeuse with other stars in the Orion constellation. It implies that we're not just centuries away from seeing its supernova, but perhaps only decades, or even less. By April 2023, galactic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe the period of anomaly had ended. In a surprising twist, the following months saw Betelgeuse's brightness intensifying by an astonishing half. Such remarkable fluctuations, while common among variable stars, were surprising for a star like Betelgeuse, which had predominantly shown predictable luminosity cycles. The abrupt and extreme surge in its brightness thrust the star back into the spotlight, igniting discussions about its future. What caused this sudden change in brightness? Why would Betelgeuse, perhaps the most recognizable star in our night sky, suddenly throw a cosmic curveball? Stars are not just shining dots in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For most celestial bodies, periodic brightness variations can be likened to the rhythms of Earth's seasons. Throughout its heavenly lifetime, Betelgeuse maintained a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it seemed to defy its established behavior, testing our understanding of the celestial phenomena above. Now you may be wondering, are we nearing a heavenly revelation? While the specific reasons for Betelgeuse's anomalies are still being scrutinized, a compelling hypothesis has emerged. This theory, focusing on celestial activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a giant celestial volcano quietly erupting and expelling a tremendous amount of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a colossal amount of its surface material into the universe. This ejection, a fantastic event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can lead to the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust scattered or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new occurrences suggest a star that has not finished astonishing us. Many hypothesize that Betelgeuse may be approaching the twilight of its life, a supernova event, a mind-boggling explosion of energy that can dominate an entire galaxy in an instant. This occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, it may result from the depletion of its nuclear fuel, causing its mass to collapse into the core and paving the way for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse launch their processes by fusing hydrogen in their cores. This initial stage, known as the main sequence stage, lasts for millions of years and forms the foundation of a star's life. As stars run nearly out of hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen diminishes, it begins to fuse helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium-burning stage is marked by the star's evolution into a red giant. Over time, as helium continues to decrease, the star undergoes further evolution and transitions into other burning stages, each characterized by the fusion of progressively heavier elements. The larger the star, the faster these changes occur, given the immense gravitational pressures at play. Then comes the peak, when iron begins to form at the core. Unlike lighter elements, iron does not release energy when fused, so the energy produced is insufficient to counteract the star's own gravitational collapse. The star swells in size and creates a collapse, followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse near the precipice of a cataclysmic end or biding its time? Recent research by Japan's Tohoku University suggests that the star may be in its helium-burning stage right now. Lead researcher Haddock believes that the core could collapse years and years after its carbon reserves are depleted. However, not all researchers agree. Contrasting studies from Hungary's Konkoly Observatory conjecture that Betelgeuse is still in the earlier helium-burning stage. The one thing that researchers do agree on, despite these discussions, is that Betelgeuse is scheduled to become the Milky Way's next supernova. Yet pinning down the timing of this event remains a grand speculative game, with bets ranging from just a few years to 100,000 years. Amidst these scientific discussions and theories about Betelgeuse's fate, one truth remains unchallenged: the very nature of our observations. When we gaze toward the brilliant stars, there's a subtle paradox we often overlook. This anomaly is rooted in the actual nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes time to reach our eyes. For example, while the speed of light is an astonishing 186,282 miles per second, it still has its limitations. Thus, the light from remote stars and galaxies takes its time to traverse the immensity of space before it graces our sight. Looking at Betelgeuse, you're truly seeing a scene from 650 years in the past. To put that in context, when this light embarked on its journey toward Earth, the Renaissance was unfolding, and travelers like Marco Polo were changing history. The light we observe from Betelgeuse today is a glimpse into a time long gone, illustrating the vastness of space and the slow passage of time across the universe. As we await Betelgeuse's potential supernova, we are reminded of the interconnectedness of our cosmic neighborhood. Each star's life cycle informs us not just about the stars themselves, but also about the processes that shape our own planet and existence. The very materials that make up our world were forged in the hearts of stars, and when they explode, they scatter these elements across the cosmos, seeding new worlds. In the grand scheme, Betelgeuse's eventual explosion will not just be a spectacle for astronomers, it will be a critical moment in the ongoing story of the universe. As it transitions into a supernova, it will enrich the interstellar medium, providing the building blocks for future stars and planets. So, as we observe this remarkable star, we find ourselves not only looking at the past but also contemplating the future. Will Betelgeuse surprise us with its spectacular end? Only time will tell, but for now, it continues to inspire wonder and curiosity in all who gaze upon it. The universe is vast, filled with mysteries waiting to be uncovered. And as we delve into the depths of space, we realize that every twinkling star carries a story, and every cosmic event invites us to ponder our place in the cosmos.